electric charge. This is the structure of an atom, and we will see the charges within an atom. Look at the structure of an atom. This is nucleus, the center part of an atom. The nucleus contains protons and neutrons. Protons are positively charged particles, and neutrons are neutral. They do not have any charge, neither positive nor negative. So protons are positively charged particles, stay inside the nucleus. Neutrons are uncharged or neutral particles. They also stay inside the nucleus. The center part of an atom is called nucleus. The size of proton and neutrons are almost same. And very small particle called electron, they orbit around the nucleus in different shells. I repeat, very small particles called electrons orbit around the nucleus in different shells, and these electrons are negatively charged particle. So this is the structure of an atom, and just by counting the number of protons, we can say which atom is this. If you count the nucleus, you see there are 1, 2, and 3 positive signs. Positive signs indicates these are protons. Plus sign. The plus sign indicates these are protons. So there are 3 protons, and you can see the 3 neutrons. So 3 protons means the atomic number is 3, and the element is lithium. So this is the atom of lithium. This is a lithium atom. So we can write here, this is a lithium atom. And lithium atom has 3 protons, 3 neutrons, and 3 electrons. And first shell contains 2 electrons, and the second shell or the outer shell contains 1 electron. So this is the total structure of a lithium atom, and it's definitely it's a magnified version. We cannot see an atom in open eyes. So we are studying charges with an atom. So what is the charge definitely with this atom of lithium? Due to these 3 protons, the positive charge is +3, and due to the 3 electrons, the negative charge is -3. So total charge, if you add them, total charge becomes 0. So overall charge is 0. The overall charge is 0 of an atom. And when this atom leaves or gain electron, the overall charge does not remain 0, rather it changes. So this is 0, and it is the overall charge of an atom. So I'm writing here. So an atom is always neutral. An atom is always neutral. So an atom is called a neutral atom. This +3 due to 3 protons in lithium. This -3, -3 is due to 3 electrons in lithium. And if we add them, it comes 0. If we add, it comes 0, remember. So overall charge is 0 for a lithium atom, and as well as for all atoms, because in any atom, the number of electron and number of proton is equal. For any atom, the number of electron equal to the number of proton. Electron numbers and proton numbers are same. That's why any atom, the charge of any atom is 0. That's why charge of any atom is 0. And when an atom leaves electron, when, important point, please write, when an atom leaves electron, it gains positive charge. And when an atom gains electrons, it gains negative charge. When an atom gives or leaves electron to someone, donate electron, it gains positive charge. Generally, metals donate electrons and become positive ion. So they become positive, they gain positive charge and become positive ion. They become negative charge and become negative ion. Right. These are important points that you have to remember. Very important points. Please write these notes. I give you time so that you can write it or you can get a screenshot. These are actually written here, but I arranged according to the points so that you can remember them easily. So these are very important points. Do not forget. So this is a neutral atom, definitely. This is a neutral atom. Charging materials by friction. Now we will read this, charging materials by friction. It is possible to charge some objects simply by rubbing them together. This is the first line, right? So if we rub any object, the object gains charge. If even the object,
Sir?
insulator, yes?
When an atom leaves electron, it gains positive charge. এটা কি স্যার অ্যাটম হবে নাকি ইলেকট্রন লিভস অ্যাটম?
Atom. When atom leaves electron. When atom leaves electron. This is atom. This is atom. This electron goes somewhere. And the atom is responsible to donate this electron. This atom donates this electron because this atom wants to gain the configuration of nearest noble gas. That's why this atom leaves this electron. It is not the electron who leaves this atom. Clear?
Yes, sir.
Atom is the responsible one, not electron. Electron is a very small one. So atom donates or leaves this electron to someone because the atom wants to be like nearest noble gas. Lithium wants to be like helium atom. That's why lithium, the whole lithium, it donates this electron. The electron does not have the power to say the whole atom that I want to leave you, because electron has nothing, no benefit. But the atom is here who is responsible and donates this electron. Hey, you leave me, you go away. I want to donate you so that I become ion, so that I gain the electronic configuration like helium. So I want to leave you because you are in my outer shell. So this is the atom who commands, not the electron. Just, it is not like the structure of diamond or graphite where there are free electrons and electrons move to conduct electricity. It is not like that. it is different. It is just particular atom. All right, electron from atom. And in diamond and graphite, we have not found that electron from atom. That electron from the structure. Atoms in diamond, what we have we seen? That is, these are atoms and electrons outside the atoms. Now these electrons are free to move. Electrons outside the atom. But now here we are studying electron inside the atom. That is the difference. You understand? This is electron inside the atom. And here in diamond and graphite, the electrons were present outside the atom. Anyway, so we are rubbing. So when we rub anything, if the object is insulator, it gains charge. Look at this. What we did. This is like just like that. For example, we can test a material that it is conductor or insulator. There is the testing that a material is conductor or insulator. Here there is a steel nail. There is a battery, and if you connect this way, the light will turn on. Look at this, the light is turned on. It means that this steel nail is conducting. And if you place here an insulator, for example, a rubber or a plastic piece, a piece of plastic, the bulb will not light on, indicating that this is insulator. So this is a very simple experiment to test. This experiment we can do also in our laboratory to test that any substance is insulator or conductor. And it is written here that there are different substances which are conductor and which are insulator. You can see here, materials, graphite, copper, tin, gold allow electricity to flow through them easily. So these are electrical conductors. And materials such as plastic, rubber, glass, wood, they do not conduct electricity. So these are insulators. Very important point. Please underline. Now look at this. There is an activity here. The activity is to investigate how insulators can become electrically charged by friction. So we get a plastic rod. This is a plastic rod, and we get a cloth. Now if we rub the plastic rod by using the cloth, now after rubbing, look at the charges. After rubbing, look at the charges. Electrons from the plastic rod, they gone to the cloth. So the
Hello,
cloth
sir.
became
Sir.
negatively charged. Yes, please.
স্যার আমার এই পেজটা পুরো ব্ল্যাঙ্ক।
তোমার এই পেজটা তোমার টেক্সট বুকে পুরো ব্ল্যাঙ্ক।
জি স্যার।
আপাতত তুমি আমার সাথে কন্টিনিউ করো। তুমি টেক্সট বুকের যেহেতু এটা পুরো ব্ল্যাঙ্ক, ইফ ইট ইজ পসিবল, গো টু দ্য লাইব্রেরি এন্ড চেঞ্জ দ্য টেক্সট বুক তুমি যেখান থেকে কিনেছো। আদারওয়াইজ হোয়াট ইউ ক্যান ডু, তুমি অন্য কারো টেক্সট বুক সংগ্রহ করে এই পেজটা ফটোকপি করে নিতে পারো। অলরাইট?
ওকে স্যার।
ইয়েস?
ওকে স্যার।
ওকে, থ্যাংক ইউ। তাহলে আমরা দেখছিলাম যে how can we charge a plastic rod? This is an uncharged cloth. If we rub this plastic rod by using this uncharged cloth, electrons from the atoms of the rod move into the cloth. Now there is an unequal number of positive and negative charges on the plastic rod as well as on the cloth. I repeat, there is an unequal number of positive and negative charges on the plastic rod and unequal number of positive and negative charges on the cloth. So as electrons jumped from the plastic rod, so there are less electrons, more protons. As there are more protons, so this is positively charged, and the plastic rod has more electrons. As it has more electrons and electrons are negatively charged particle, the plastic rod gained negative charge. So the plastic rod is positively charged and the cloth is negatively charged. Plastic rod is positively charged after rubbing and the cloth is negatively charged. Now look at this. Now that plastic rod is this. The plastic rod is positively charged. Now if you brought closer another plastic rod of similar charge, this plastic rod is hanged or suspended by a thin thread, and another plastic rod is brought closer, similar charges repel. So this hanged or suspended rod would move away, showing that similar charges repel. And if you brought another plastic rod of negative charge to the suspended rod, you will see that the suspended rod comes closer. It shows that opposite charges attract. So this is the nature of charge, and very important point, please write: similar charges repel and opposite charges attract. Very important point. Similar charges repel and opposite charges attract. So this is a very good demonstration, and what you need to do, this demonstration is important for O-levels examination. You have to draw it, and this labeling. The question is that show by drawing a diagram that similar charges repel and opposite charges attract. This question, and this is the answer. The answer is this. You have to draw the whole diagram with appropriate labeling. You don't need to draw the hand. If you do not draw the hand, no problem. You don't need to draw the hands. All right. So this is the one, the paragraph. It expresses that charged objects can exert forces on other charged objects without being in contact with them. How important this line is. Very important. Look at this. They do not have contact. Still, they have force on each other. If the charges are similar, they repel. If it is opposite, they attract. Very important line. Very important paragraph. Next, this is a demonstration. This demonstration is that Venn diagram generator demonstration. Venn diagram generator is a device that produces static charge. Venn diagram generator, if you touch, you would not get shock. It has a dome, and the dome is large dome, and the dome is charged, and the girl touched the dome, and charges now all around the body and head of the girl, and look at her hair. The hairs, it gains similar charges, they repel, and so hairs are scattered everywhere. It shows that the hair gets similar charges. The girl's head has the same charge, and they repel each other. So building up of static electricity means that each hair on the girl's head has the same charge, and they repel each other. Each hair or each strand of hair has the same type of charge as its neighbor. There are repulsive forces between the strands. So the strands of hair repel each other. These forces cause her hair to stand on end. So this demonstration has been done using Venn diagram generator, the device or the machine's name. And there is a dome which is charged. Now look at this. Forces between charged and uncharged object. Look at this diagram. This balloon is negatively charged, and this wall is neutral. It's a neutral wall. This balloon is negatively charged, and this wall is neutral. When the balloon is brought closer to the surface of the wall, opposite charges like inside the wall, like negative charge as the balloon. They repel and they are moving away. Oppositely charged or negative charges present on the wall repelled by the negative charges present on the balloon, and negative charges of the wall, they are moving in opposite direction, and positive charges of the wall, they come closer or they stay with the wall, and the balloon stick with the wall for a small time period, shows that opposite charges attract. You can do this experiment at your home, you can try. That's why what you need to do, you have to rub the balloon, make the balloon charged. And rubbing, you can do it by using dry cloth, very dry cloth, rub the balloon. Be careful, the balloon must not burst. So the balloon gets charged, and if you just put the balloon with inside on the surface of a wall, it may stick, showing that oppositely charges attract each other. So this is a very good demonstration. This is another demonstration. This ruler, look at the ruler. This ruler is rubbed by a cloth, dry cloth, and ruler becomes charged. We considered that the ruler becomes positively charged. It is not possible for you to understand that the ruler becomes positively charged or negatively charged because you cannot see the charge. You cannot see it. What you can do, you can just do the experiment using the charges. It is not possible to look at the charge until and unless you connect the charge object into a circuit. When you connect the charge object into a circuit, and when you observe the flow of current, and when you observe the direction of current, then only you can say that it is positive or negatively charged. And that's why you need some devices, such as you need ammeter, you need voltmeter, or you may need some other devices. But anyway, we are not going in that direction. We do not have to find out that whether the charges after rubbing is positive or negative. We just need to find out that after rubbing it gains charge, either positive or negative. Now this ruler is charged. Now there are some small pieces of paper, and if you brought the ruler, charged ruler, rubbed and charged ruler, this is a rubbed and charged ruler. I can write it here so that you can understand. Rubbed and charged ruler. All right. If you brought now closer to some small pieces of paper, these small pieces of paper are neutral. Neutral, small pieces of paper. If you brought this ruler closer to the small pieces of paper, the ruler will attract the small pieces of paper. Why? Because look at the paper, look at this. I magnify for you. The opposite charge, negative charge, present into the paper are attracted by the positive charges present onto the ruler. That positive and negative, there is an attraction. Due to this attraction, these pieces of paper will be sticked with the ruler. You understand? So this is another demonstration that attractions present between opposite charges. And there is gold leaf electroscope. There is uses of electricity, and gold leaf electroscope is also the same thing. Just like this is an electroscope, there is a gold leaf here. A gold leaf is used. Look at the total leveling. This is a metal plate. There is the gold leaf. There is the metal rod. This is the metal plate. It is used by gold. The leaf is used. It is a very small, thin sheet that is called just like as leaf. That's why it is called leaf. It is actually a metal, thin metal sheet, and it is made by gold. Why gold? Because only gold is suitable to make it thin, as much thin as possible. gold is the suitable metal because gold has very good ductile and malleable property. Especially malleability is the property which is used here. So when we brought a charged object, this is the charged rod brought closer on the metal plate of electroscope. This is the whole machine is electroscope. When a charged object, charged metal rod or plastic rod is brought closer to electroscope, look at the metal plate condition. All the positive charges repel. All the positive charges gone here. Now, what is the result? Due to the positive charges, the leaf, look at this. It moves away because positive charges repel. And all the negative charges here. And look at the demonstration here. All positive and negative charges are equally distributed when it was neutral. But when you brought closer a charged object, the neutral system gone. All the negative charges here due to positive and negative attraction, and the positive gone here due to repulsion. Between positive and positive, there is a repulsion. So positives are here, positive charges are here. You can say charges. And look at the deflection of the leaf. So the leaf deflected, showing that opposite charges attract here and similar charges repel here. So it shows both experiments. Here it shows opposite charges attract, and here it shows similar charges repel. And if you brought closer a negatively charged rod, similar thing happens. Here it shows opposite charges attract, and here it shows similar charges repel. Understand? It's a very good demonstration. So drawing this diagram is also very important. Labeling this, please look at this: charged plastic comb, metal plate, deflected gold leaf, metal rod. You must know the different parts of the electroscope. And this total demonstration has been done by using static electricity. What is called static electricity and what is called dynamic electricity. Rubbing or friction produced electricity, this is static electricity. And the electricity that we use at our home, that is not static electricity. That is, you can consider dynamic electricity. And that is static, though that dynamic electricity is not said in language, that is electricity. And this is static electricity that is produced due to rubbing or friction. When there is a friction between the clouds, it also produces static electricity. Remember what I said? When there is a friction between clouds, I can write it here for you. So relevant, when there is friction in clouds, it produces static electricity. All right. Okay. And there are some uses of static electricity. By using static electricity, a bicycle, frame of a bicycle, metal frame, definitely, it can be painted. Look at the nozzle. Spray come out through this nozzle, and it has similarly charged. It is charged when it is coming out. It is being charged, and all the charges are similar, so it is sprayed. And bicycle must be oppositely charged before, so that the opposite charges attract, and each corner is painted perfectly, properly, and less wastage of spray due to this demonstration. So this is one, and there is another one. There is inkjet printer. There is another example, photocopiers. There is another example here for the precipitators in industry. You don't need to read detail about it, but you just need to know the example names. In a photocopier, we use static electricity. In photocopier, we use static electricity. In inkjet printer, we use static electricity. In bicycle painter, we use static electricity. And in electrostatic precipitator, static electricity can be used. These 4 applications of static electricity, I can write it a note for you. Different applications of static electricity are as below. Number one, the metal frame of a bicycle. First off is a bicycle painter, the metal frame. Look at this metal frame. So bicycle metal frame painting is by static electricity. So first one is bicycle painting. Number two, look at this. Number two was this inkjet printer, this ink guns. Detail, you can read it just a while to get the knowledge. Otherwise,